Good morning, ladies and gentlemen. It's a privilege for me to bring my presentation today. I'm so sorry I can't attend by person. I would like to say thank you so much to the committee who let me bring this virtual presentation. I'm Dr. Wedagama and my team did this research together. I'm a senior lecturer from Mahasaraswati University in Bali. Our university is located in the heart of Bali Island. Bali is one of the most beautiful and visited islands in Indonesia. It is well known by its beautiful wave for surfing. Indonesia is located in Southeast Asia between Malaysia and Australia. At the right corner of the picture is our university. In Bali, my university is the only university who has dentistry faculty. The title of my research is Proliferation of 0% and 10% nanokitasen and platelet-rich plasma from pre-osteoblast cell with Ki67 as a surrogate marker in vitro. On medical science lately, many techniques are being made to fill bone defects, such as bone defects due to tumor resection of bone, apex resection of tooth or bone caused by trauma. Wound forming on surgical method require bone healing, bone remodeling. To accelerate the process of bone healing, bone graft material is required which is capable of acting as a physical barrier that serves as osteoconduction, osteoinduction, and osteogenesis. Nanokitasen is a biopolymer that can accelerate bone formation, bone healing, biocompatible, biodegradable, and anti-microorganism. Adding platelet-rich plasma on nanokitasen as a scaffold expected as a function of the delivery vehicle for cells, osteocompetent, and for growth factors, and regulate the process of bone healing by acting as extracellular matrix and maintaining the space and shape of the bone defect remodeling. Here is the methods. The main material used in this study was nanokitasen, nephrovidae, Bali seashells that have been processed into nanoparticle size with ball milling techniques. Platelet-rich plasma taken from the blood of researchers supported by the Indonesian Red Cross workers, Malang branch, which is processed by the centrifugal technique, and marker Ki67 obtained from mouse, cell culture media pre-osteoblast MC3T3E1, 80 cc murine cell line. The pre-osteoblast culture. Plating pre-osteoblast cell culture, pre-osteoblast cell media MC3T3E1, 80 cc murine cell line using alpha, MEM, 2 mm L-glutamine, 1 mm sodium pyruvate, 10% FBS, and 10% pen strap in the butterflies, 25 cm square, and incubated in an incubator 5% CO2 at 37 degrees Celsius until 70 to 80% confluent cells. Once confluent, cells prepared in plating in well 24 for treatment. Blood sample on the investigators was taken to obtain PRP with centrifugal technique in PMI Malang, assisted by PMI worker. Pre-osteoblast culture cell treated with nanokitasen and PRP within 5 and 7 days incubation. Here is the result. Immunocytochemical done to study the distribution of specific enzymes in the cell structure intact to detect the cell components, biomacromolecules. In this examination to see pre-osteoblast proliferating cell staining. Cell proliferation by test immunocytochemical observed by confocal laser scanning microscope CLSM. This picture shows overview of pre-osteoblast cell proliferation in immunocytochemical description. The red figure shows the absorption bonding primer Ki67 antibodies with anti-MOS secondary antibodies labeled rhodamine C. And the table at the bottom is the result of normality test data. The description: if the p-value of less than 0.05 means that the data were not distributed normally, and if the p-value more than 0.05 means data distributed normally. The discussion: significant difference P less than 0.05 in the mean proliferation of 0% and 10% between treatment groups nanokitasen plus PRP incubation 5 and 7 days in the treatment group hydroxyapatite plus PRP based on the average value proliferation of 0% and 10% seen in the treatment group nanokitasen plus PRP incubation 5 and 7 days is much greater in value when compared with the average proliferation of 0% and 10% in treatment group of hydroxyapatite plus PRP. This means that the treatment of nanokitasen can accelerate bone and PRP healing with incubation time 5 and 7 days compared to the treatment group hydroxyapatite plus PRP. It is appropriate said that proliferation cells show good results in a concentration of 5% on the day 7. Experiments stated that chitosan can minimize oxidation directed by peroxide value, change the color and the number of microbes in sample. Also reported that an increase in abnormal cell proliferation pre-osteoblast humans when exposed to chitosan coating with a degree distillation greater than 90%. Nanokitasen in a greater percentage can induce formation of new bone formation greater than the formation of femur defect on bone. The conclusion: nanokitasen plus platelet-rich plasma can accelerate proliferation than the hydroxyapatite plus platelet-rich plasma on concentration either 0% or 10%, so that the bone healing process becomes faster by giving nanokitasen plus platelet-rich plasma. Recommendation: more research, especially focused on bone regeneration using PRP nanokitasen application. The outcomes of this study: natural products for bone regeneration and decreasing the use of chemical products for bone regeneration. Here is some of bibliographic entries that I use. Thank you for watching my virtual presentation. I hope that this presentation can be useful for us. Good morning.